Okay, continuing on with finding a Fourier approximation. And for exercise 77, okay, we have that f of x is equal to pi minus x, and we're looking at finding out the Fourier approximation where we have carrying out to the third order. Okay, so we'll be looking for a naught as well as a1, a2, and a3, as well as b1, b of 2, b sub 3. And for a naught, again, we have with the formula, we have 1 over pi times the integral as x goes from 0 to 2 pi of f of x. And with f of x at pi minus x, okay, we have the antiderivative of this different statement to be pi x minus x squared over 2. And applying the integral formula, we have with the limits, with the lower limit at 0, the upper at 2 pi, okay, we're going to have that a naught ultimately is going to come out to 0, because what happens is that as x is equal to 2 pi, the expressions become 2 pi squared and negative 2 pi squared. So those cancel out, and at the lower limit 0, the terms are also negligible. Okay, so a naught is equal to 0. Now, where we have, in the case of a sub j and b sub j, again, now for a sub j, we're going to be looking at integration by parts, whereupon we have the integral of pi minus x times the cosine of jx dx, and just carrying out what we have here. So we have u is equal to pi minus x, and taking the differential, so du is equal to negative dx, and for dv is equal to the cosine of jx dx, the antiderivative, we're going to have 1 over j times the sine of jx. And with the integration by parts, we got u times v, so that's going to be pi minus x all over j times the sine of jx. And for minus the integral of v du, that's going to translate to the addition of 1 over j times the integral of the sine of jx dx, and integrating over the sine of jx dx and following through, we're going to have the antiderivatives to be pi minus x all over j multiplied by the sine of jx minus 1 over j squared times the cosine of jx followed by the constant. And for what we have relaying over to the numerical integration, okay, so we have, again, taking 1 over pi times the integral as x goes from 0 to 2 pi. Now again, you had the sine of 2 pi is negligible, as well as the sine of 0. And for the cosine of 2 pi, okay, that is going to be at 1, and the cosine of 0 is also at 1. Okay, so we have from the upper limit, we have negative 1 over j squared, and we have also in the mix, okay, we have in the process, okay, we're going to have minus the quantity, and we have 0 minus 1 over, and that should also be over j squared, and we'll have minus 1 over j squared plus 1 over j squared, and that is going to be negligible. So everything in a, okay, along with a naught, we have a sub 1, a sub 2, all the way out continuously is going to be equal to 0. Okay, now looking at what we have for the coefficients originating from b sub j. And again, we have b sub j is equal to 1 over pi times the integral of f of x times the sine of jx dx. Okay, and again, the f of x, we have pi minus x. And carrying out what we have with the integration by parts. So we have that u is equal to pi minus x. The differentials, we have du is equal to negative dx. Now for dv, we have the sine of jx dx. Antiderivative, we have negative 1 over j times the cosine of jx. And carrying out with the u times v minus the integral of v du approach, we're going to end up, okay, now with the negative of pi minus x over j times the cosine of jx. And we have minus 1 over j squared times the sine of jx, followed by the constant and the negative of the quantity of pi minus x. We can write that as x minus pi over j, cosine of jx, minus 1 over j squared sine of jx, followed by the constant. and carrying this over to the numerical integration. Okay, so we have in this one case, you got 1 over pi times the integral pi minus x sine of jx as x goes from 0 to 2 pi. And again, we have with the antiderivatives. And again, so we're going from 0 to 2 pi. Okay, so at 2 pi now, the cosine of 2 pi is 1. And here with 2 pi, so you got 2 pi minus pi, that becomes pi. So we have pi over j times 1. And again, sine of 2 pi is 0. And with the lower limit at 0, now you're going to have negative pi. 0 minus pi is negative pi over j. Cosine of 0 is 1. And again, sine of 0 is 0. And just filling in. Okay, so we have 1 over pi. And the difference from what we have to emanate from the upper and lower limits. Okay, we have 1 over pi times 2 pi over j. And that is going to be lowered to 2 over j. And we have with the coefficients in b. So you got b sub 1 is equal to 2 over 1, which is 2. B sub 2 is equal to 2 over 2, which is 1. B sub 3 is equal to 2 over 3, and so on. And so for what we have at the order n is equal to 3, we have for the Fourier approximation at the order n is equal to 3. Again, a naught and the remaining terms with the coefficient a. Okay, all of those are negligible, so we have everything is going to be riding upon what we have to result for b. So carrying on what we have here, so we have for the approximation of third order, we had that g of x is equal to 2 sine of x plus the sine of 2x plus 2/3 of the sine of 3x. All right, now for what we have in the case of the same function but carrying out to the fourth order, okay, at orders n equal to 4, we had the exact same terms, but now we're adding another item, and that's going to be where we have b sub 4 of the sine of 4x, and b sub 4 is going to be 2/4, and that lowers to 1/2. So for g of x, we have 2 sine of x plus the sine of 2x plus 2/3 of the sine of 3x plus 1/2 of the sine of 4x. Now, the next item, very, very tricky. We have f of x is equal to e to the negative 2x, and we're looking at just the first order. And thankfully, just the first order. And now for a naught, okay, you got 1 over pi times the integral as x goes from 0 to 2 pi of f of x dx, where f of x we have e to the negative 2x. Now the antiderivative is going to be negative 1/2 of e to the negative 2x. And as x goes from 0 to 2 pi, we're going to end up with a naught equal to what is going to be negative 1 over 2 pi times the quantity of e to the negative 4 pi minus 1. Now, for what we have for a sub j, again, we're looking at 1 over pi times the function times the cosine of jx dx. And here we are re-entering the zone of integration by parts, and not just integration by parts, but repeating integration by parts. So for e to the negative 2x cosine of jx dx, if I set u equal to e to the negative 2x and dv equal to the cosine of jx dx, and we have in the differential statement du is equal to negative 2e to the negative 2x dx. V we have at 1 over j times the sine of jx. And for what we have here and following through, so we've got the uv combination and minus v times the integral of du, and this will translate over to addition and repeating the integration by parts. And we have inside the integral, or the integrand, we have u is equal to e to the negative 2x. Differential we have at negative 2e to the negative 2x dx. dv we have with the sine of jx. Antiderivative we have minus 1 over j cosine of jx. And so just continuing, okay, so got 2 over j times all of, again, u times v minus the integral of v du. And once we distribute 2 over j, we're going to end up with like integral terms with what we started out with, and to the right we have minus 4 over j squared times the integral of the exact same terms. And if I combine like integrals together, so I can say that I have 1 plus 4 over j squared quantity times the integral of e to the negative 2x cosine of jx dx is equal to these particular terms, and then isolating, so I can take the multiplicative inverse of this coefficient. So I can say that I have 1 plus 4 over j squared, okay, to the negative 1, and then we have times all of what I have with the combinations in e, as well as the sine of jx and the cosine of jx, and that's going to be followed by a constant, and taking what I have in j and x and the antiderivatives and applying to the numerical integration. Okay, so as we go from 0 to 2 pi, and yeah, those expressions do get to be a bit crowded. But again, the sine of 2 pi as well as the sine of 0 is 0, and the cosine of 2 pi is 1. Cosine of 0 is also at 1. And looking at what we have, again, e to the 0 is going to be at 1. But now we got for e to the negative 2x, if x is 2 pi, well, guess what? We're going to have e to the negative 4 pi as the exponent. And looking at combining our terms, and what we're going to have in the result is that for the numerical integration, okay, very complex. So we got 1 over pi times the multiplicative inverse of 1 plus 4 over j squared, and we have times the quantity of what's going to be reducing to negative 2e to the negative 4 pi over j squared plus 2 over j squared. And for a sub 1 with j equal to 1, okay, so you're going to have like 1 plus 4, which is 5 to the negative 1, and the multiplicative inverse of 5 is 1/5, so I can just say 1 over pi times 1/5, so I have 1 over 5 pi, and I can say I have times all of negative 2e to the negative 4 pi plus 2. And for the b sub j terms, okay, so again, integration by parts, where I have interaction between e to the negative 2x and the sine of jx. And again, we have same kind of follow through, where you're going to have repeating integrations by parts, and you're going to have like integral terms, okay, and we have like integral terms with those involving e to the negative 2x, sine of jx dx, combining, so I have the quantity of 1 plus 4 over j squared times the integral, and I got these antiderivative terms already established from the earlier integration by parts stages, and then isolating the integral. Okay, so I'm taking the multiplicative inverse of 1 plus 4 over j squared times our antiderivatives already established, and since we're looking at a general integral, we have followed by the constant. So for this multivariable statement, I'm going to apply into the numerical integration realm. Yeah, there is quite a bit of crowding at this point, but as we go from 0 to 2 pi, okay, so again, cosine of 2 pi and the cosine of 0 will be equal to 1. Sine of 0, sine of 2 pi will be negligible. And for the non-negligible terms that remain, we're ending up at 1 over pi times the quantity of 1 plus 4 over j squared to the negative 1, and we have times the quantity of negative e to the negative 4 pi over j plus 1 over j. And with j equal to 1, we have the coefficient b sub 1 is equal to 1 over 5 pi times the quantity of negative e to the negative 4 pi plus 1. And going back to what we have in the case of the layout here. Okay, so for g of x, okay, filling in, again, we had a naught, okay, was in this particular case equal to negative 1 over 2 pi times the quantity of e to negative 4 pi minus 1. So taking half of this, we got negative 1 over 4 pi times the quantity of e to negative 4 pi minus 1. And again, with the a sub 1 and the b sub 1, okay, we have 1 over 5 pi times negative 2e to negative 4 pi plus 2 times the cosine of x. And we have plus 1 over 5 pi times the quantity of negative e to the negative 4 pi plus 1 times the sine of x.